All right, on this video, we will present how to create a new wallet, how to preview a wallet, and how to decrypt a wallet. So on the documentation, we have those three endpoints there. So first, we start by reading what it says on the create wallet. By the way, you can just go to docs.self.world and you can start exploring the API documentation for the online version. So let's be clear, we have an online and offline version. On this series of videos that I'm doing right now, they're focused on the online version. So the first endpoint that we will discuss is the post for creating a new wallet, which is API slash wallets. This endpoint will create a brand new self-proof as a raw byte encoded in base 64. They're the same bytes used to generate the QR code. Just the QR code has a binary encryption. That way, it reduces the size when putting in a QR code. So before we get started, the web extension that we are building for Self utilizes an additional encryption, which is the PGP encryption. This is only for us to manage the information from the front end to the server. So the communication is safely transmitted through those two ends, right? So this process is very simple. First, we will get a public key that we call it a session, the PGP public key. This key will be used to encrypt every message that we consider private with this public key. So each session, which means each user gets a different key. So decrypting the content will require to match the same secret key that we assigned to that session. So it all depends on that device. So we will generate a brand new key depending on the device, the time, and some other factors that will make it pretty unique in that matter. So this is a post call. Um, Also, just to make it clear on this series of videos, I'm not going to encrypt it with PGP since we're not using the web extension. We're using Postman. So everything that says PGP encrypted message is going to be just the raw content. But we have a parameter at the end that says remove PGP. That way, we send the information without the PGP encryption, so we kind of bypass those validations. So the first parameter is the face. So you want to make sure that you take a photo, a selfie of yourself, and then encrypt it. Transform it into a base 64 format. Then you specify how many words you want to have your wallet. So it can be either 12 or 24. In this case, we're specifying 12 here, but we put in 24 on this end. Um, the OS, it means that you can specify if you want to put it on the self-proof that it was encrypted on a desktop, which means it's a web extension, or on a mobile, so it can be Android or iOS. We can also specify a password. So this is considered a second layer of security. So the first layer and the most important layer is the face. But um, if you feel that you want to add a second layer, you can put a very hard password or a simple password, numeric or characters. It doesn't matter. You can put whatever you want there. So before you put your face, you have to input the password. So it passes the first layer of encryption, and then the second layer is the face. Once we put those together, um, we can figure it out later that okay, those combined can decrypt the self-proof. We can also add a server password. This is a third layer of security. Let's say you have a server where you're using our technology. You can specify a password. Let's say I don't know, one, two, three, four, five, six. So you put your face, you put the password that you set up, and then you need to specify that only your server can decrypt it. So we add that third layer of security. That combined creates the safest self-proof that you can have. But I would say that by my recommendation, the face and the password, it's more than enough. So the face base 64 is just a selfie, like I mentioned. The words count, it can be 12 or 24. The password, it can be anything. You can put the password that you want. When using PGP, we encrypt it, so the password is transmitted through HTTPS via an encrypted message. So the server can decrypt it because we, at the beginning, gave you the public key and we have the private key. So once we send everything, we get a response something like this. So let's test it right now. I want to create a brand new wallet with my face, and I want to see the wallet. This is a parameter that we can have if we want to see what's going on the metadata, on the private part of the encryption, but this is optional. The metadata is basically your wallet. All right. So this one created a brand new wallet. So let's analyze what's inside here. We have an image. Well, this anonymous, it means that we're not tracking anybody. So as long as you send the request, we don't know who did it. So based on later on the plans that we will provide, we have a free version, we have a pro version that have access to the offline version of the encryption, which means you can run it offline in your phone and without the need of internet and without the need of using any cloud computing. Then we have the image. The image is basically the base 64 representation of an image. So if we go around and do like base 64 to image and we paste it right here, we can get the QR code. So what's inside here? Here's the binary representation of the self-proof, which is this one. This is what actually we need to safeguard, but it's easier to save an image because you just put it in a gallery of your phone or put it somewhere safe, right? You can even print it. And printing a text is not as cute or easy to save, for example, on Google Cloud or Dropbox or whatever you're thinking of, right? Um, so on the public data, this is the information that you can access, um, that you can access without decrypting the content. So you don't have to put your face, you don't have to put the password in order to see this information. This is useful because you can just scan it and say, oh, this is the QR code to decrypt X wallet that I created last month, because you're looking at the Ethereum address or the Solana address or any address. Here on this example, we're only putting two blockchains, but this is gonna be a multi-chain. Why? Because the mnemonic mnemonic phrase, sorry, um, can be translated to private keys in most of the blockchains. So Bitcoin is one, Ethereum, Solana. It doesn't use the 12 words or the 24 words, but it can be converted with a library, and it creates the private key. So all the blockchains are kind of like compatible, right? So you can create all the wallets with one simple uh, um, metadata that you have in your self proof. So now let's just go to the other endpoints. I think I copied the self proof. Yeah, it's here. All right. So I'm gonna do preview wallet. I'm gonna input my brand new self proof, and it's gonna tell me almost the same that we saw on the other one, but simpler. Why? Because we don't have the fees and we don't have the password. Um, or right now it doesn't require a password, which is has password false. This one require liveness, yes. Password layer, no password. So only requires the face. The public data, we have the ID, the Ethereum address, the Solana address. All right, so we have these three variables as well here. So that's good. We know that this is a self-proof that doesn't have a password and it has this public data and it requires liveness. So now I'm gonna make sure that I can copy this again. Um, and I'm gonna go to the decrypt function. I'm gonna input my brand new self-proof and my face, and I'm gonna click send. Oh, this is the endpoint is my wallet decrypt. Verification failed. Let's check what's going on here. This might be using a different face. Let me just copy the face that I have here. Okay, copy this. Go all the way down. You know, when you take a selfie, it's like it has a lot of pixels. Comparing that in a base 64, it's a big string. I'm gonna come here and replace it. Put it here. All right. So utilizing the same face, probably I was testing with a different face of a different person there. So anyway, so I have the same face which can decrypt it. If we let's just go back to the documentation. Um, okay, this is importing a wallet. Let's go back here. Um, Preview a wallet, which we already saw it, and decrypt a wallet here. All right, so this one, the documentation is here. The endpoint is API my wallet decrypt. This endpoint is used to decrypt a wallet by taking the self proof and the password, which is optional if not set. The logic here is very simple. You're required to pass a selfie to do a liveness test, and then we utilize the face to decrypt the information inside the self proof. Simple, right? So, based on that, I'm gonna just go here and tell you that we have all the requirements. We have the self proof, we have the face and the selfie, and I think I didn't set up a password because it didn't require it. Then anytime I wanna decrypt it, let's say I encrypt it as many times as I want, it will return the exact same information because that's how it works. Um, so the image is here, which means that this is um, the QR code. We have the self-proof back again here. Um, we have the public data, we have the metadata, we have the ID, and everything that we put there is going to be encrypted here as well. So those are the three endpoints that are more important for analyzing the logic behind the self wallet.